Okay, I'm going to have a look at 2019, and the AP GP question is 12A. And it's saying prove that the sum of the numbers, n numbers in an arithmetic progression with first term A and last term L is what we have in beneath. So this is probably the easiest way of doing it. The sum of the numbers, first term, the next term is A plus D, the next one is A plus 2D, and we go the whole way up. Now they're talking about the last term, calling it L. So we have the last term here, and the one before the last term with the last term, take away the difference. Write that in reverse. So write the last term first, write the one before the last term in here, the whole way up, write the second term up here, and now write the first term. Add those two together, so you get 2SN equals A plus L. This here section cancels to A plus L, the whole way up to this. These here two add to L plus A, and the last two add to L plus A. You've got n numbers, so in fact you have got n of these brackets. So 2SN is n of these brackets, A plus L. Bring your 2 across and divide. So n over 2, A plus L. The second bit, part in that, is saying find the sum of a GP. Sorry, the first term of a GP is 7. So let me just write that out. So I'm on to part 2. So the first term is 7, the last term is 79, and the sum is 1075. The easiest way is probably just use the formula up above there. So Sn is n over 2, A plus L. Don't often use that formula, but it does make sense in this case to use it. N over 2, A plus L. So bring this 2 across and it becomes multiplying, which gives you 2150 equals n. Adding these together, 86. Bring your 86 across and divide, you've got 25. Now, part 3 of that question is asking you to find the common difference. Now, the last term of that is A plus n minus 1D. You know you've got 25 terms. So the 25th term is actually the last term, which is 79. So we're just plugging that into your formula there. So 79 is A, you have them up here, 7, plus n, that you know is 25, n minus 1, gives you 24. Rearrange this, bring your 7 across and subtract. So you get 72 equals 24D, so you've got D equals 3. Now, on to part B. Part B. A salesman receives a bonus at the end of each year and decides to invest this in the money in the savings account. At the end of year 1, he invests £400. At the end of year 2, he invests another 400, plus receives 2% interest on his first year's 400. So he's got 2% on this. So this value from year 1 will now be worth 102%, and 102% is 1.02 times 400. Year 3, he invests another 400, and he gets 2% interest added to the money he's accumulated to the first 2 years. So he has 2% more in this. So he starts off at 100%, add the 2%, he has 102% of this. So 102% of this amount of money here. 102% is just 1.02. So it's 1.02. 400 add 1.02 times 400. Tidying that up, you're always looking for patterns for these. That's where my biggest piece of advice is, looking for patterns. Add 1.02 squared times 400. Now, the question says, show that much he has in account at the end of year 3. So if you just work that out on your calculator, you should get the answer there, 1, 2, 2, 4, 16. Part 2, now is assuming that he continues to invest this way, prove this. Now, let's have a look at our pattern that's going on here. Year N, 400 plus 1.02 times 400 plus 1.02 squared times 400. If you have a look, Year 3 went up to squared. Year 2 went up to the power of 1. So year n is going to go up to the power of n minus 1. So it will be 1.02 to the n minus 1. So yes, 3 went up to 2. So year 4 will go up to 3. So year n will go up to n minus 1 times 400. You can now see this as a GP because you're multiplying between the terms. The first term is 400. The ratio is 1.02. And the question now is wanting to know the sum of the money. So Sn equals A over 1 minus Rn over 1 minus R. I tend to use that formula if R is beneath 1. So I'll just write it the other way around. R minus 1. Now, you know that A is 400. R is 1.02. N you don't know, take away 1. R 1.02, take away 1. Now, if you go into your calculator and put in 400 divided by 0.02, you should get out the 20,000 that they're looking for on the screen there. So it's 20,000 times 1.02 n minus 1. And the last bit of this question, hence find the least number of years until his investment exceeds 7,000. So I'll take a bit of space here. So I want to know when does his investment exceed 7,000. Now, SN formula from up above is there. Even if you couldn't get this part of the question, you can still use it from the actual question sheet there. So just use the formula that they've given you. So you want to know when does this exceed 7,000. So bring your 20,000 over and divide first of all. So bringing that across and divide, you should get 0.35. Bring your 1 across and add it on. So it's 1.02n greater than 1.35. You now have an exponential. So the power is the n. To solve exponentials, you log each side. So just logging each side, you bring the power forward. Now bring the log to the other side and divide. So n is greater than log 1.35 over log 1.02. Right, space here. That will tell you that n is greater than 15.2. So i.e. you need 16 years. So it is important that you finish up at the end. So 16 years there at the end.